All right, now it runs on the window. Cool. Okay. Right. Everyone just present the stuff that they, write in the document, you know,
Okay.
and you don't already put in everything, fucking everything. So you don't need to check the document.
Okay.
All right. OBS recording.
Go submit your Discord, please.
Oh shit! Really?
Uh,
All right. Yes, it's recording. All
what
right.
just happened?
You good?
I'm not. Wait. Okay, I'm good. Let's go.
All right. Hello. Good morning, good afternoon, and good evening. We are from Group 6, and today we'll be presenting about server system architecture. And first, let's have our introductions. These are our group members. I myself am Muhammad Tadin Gosan Susilo.
And my name is Muhammad Alizidan Maisa.
And I'm Edward Wong.
Right. And because we only have three members, we all contribute well in making articles and the presentation PPTs. So rest assured, we all participated, and these are all our group members here. Now, let's start immediately. Now, the definition of a server system. Server systems are powerful computers, are software that provide resources, data, services, programs to other computers or clients over a network, forming the backbone for web hosting, email, databases, and more, using specialized hardware and operating systems like Windows Server Linux for high reliability, performance, and centralized management of network activities. Now, they handle heavy workloads, serve many users simultaneously, and ensure data security and accessibility, operating continuously to support business and online functions. Then this is your part.
Okay. So the next part is wait, what? The next part is the concept of server system architecture. So the definition is the server system architectures refers to the structural design of servers, including how servers are organized, communicate, and distribute workloads to provide service to clients. The basic component is the first one is the client, and second one is the server, is the third one is the network, fourth one is the load balancer, and the last one is the database system. Next, we're gonna talk about the types of the server system architecture. So here is the first one. There's a single tier architecture. So the single tier architecture is a client, application, and the database exist in one server. The advantage of using this is a simple design and low cost, but disadvantage for using this is a poor scalability and high risk of system failure. Next one, we have the two-tier architecture. The client communicates directly with the server or database. The advantage of using this is we have the better performance than single tier, and we also has the simple implementation. But disadvantage for using this is a limited scalability and high server load. Also, there's a advantage of and a disadvantage of the types of the server system architecture. The advantage is a scalability and load balancing, fault tolerance, better system reliability. For the disadvantage is a complex configuration, requires skilled administrators, increased infrastructure costs, and here is the real world use cases. Example, we have a e-commerce platform like Amazon, Shopee, or maybe Tokopedia. And second example, we have the streaming service like Netflix, YouTube, or Twitch. The last example, we have the cloud service, the AWS, Google Cloud, or Azure. These systems commonly use multi-tier server architectures with load balancing and distribute servers. Next one, this gonna
Right.
be
Yeah, it's my
explained
part.
by Gosan.
Right. So when it comes to server system architectures, there are mainly two types that are discussed. First, there are transaction servers, and also there's data servers. First, let's talk about transaction servers. Now, by definition, a transaction server can also be referred to as a query server or an SQL server systems. A transaction server is a specialized middleware component that manages and processes business transactions, ensuring they are completed reliably and consistently, often involving database reads, writes, coordinating multiple steps, and communicating results back to the user or system. And here are the core functions. Now, the core function of a transaction server are the transaction management, which executes multi-step operations as single atomic units or as asset properties, ensuring all parts succeed or none do. Then there's data handling, reads, writes, and updates your database efficiently. And moving on to with our explanation, so we don't take much time. There's coordination, automation, event progressing, and other core functions like clients send requests to the server, transactions are executed at the server, and results are shipped back to the client. And as for the structure, a transaction server structure typically involves a multi-tier system, a client, which is the presentation layer for user input, a request controller, the transaction server or the logic or processing layer, handling business rules, and atomicity, and a database system, data layer for persistent storage, with middleware facilitating communication and ensuring data integrity, which is asset properties, across these components. And here are the key details. These transaction servers have shared memory contains shared data. All database process can access shared memory and perform periodic checkpoints, output modified buffers, block the disk continually, and so on and so forth. Edward?
This is for the second type, which are data servers. In data servers, data items are shipped to clients where processing is performed, then these updated data are written back to the server. In the early generations of data servers, these will be operated in units of data items or pages containing multiple data items. In the current generation, the data servers, also called data storage systems, only work in units of data items. Commonly used data items formats include JSON, XML, or just uninterpreted binary strings. Then these are the core function of data servers. First, we have prefetching, which is to prefetch items that may be used soon. Then we have adaptive lock granularity, which can lock granularity escalation, switch from finer granularity, like tuple, to lock to coarser, and then lock granularity de-escalation, and then start with coarse granularity to reduce overheads, then switch to finer granularity in case of more concurrency conflict at server. Then the third one, we have data caching, which means data can be cached at client even between transactions, but it must be checked so that the data is up to date before it is used. These checks is what you can call cache coherency. A check can be done when requesting lock on a data item. Then the fourth one and final, we have lock caching, which means locks can be retained by client system even in between transactions. Transactions can acquire cache locks locally without contacting server. Then the server calls back locks from clients when it receives conflicting lock requests. Client returns lock once no local transaction is using it. This is similar to lock callback on prefetch, but across transactions. Next. Yeah. We have our conclusion, which is the server system architectures are essential for building scalable and reliable systems. Choosing the right architecture depends on system requirements, user load, and budget. Modern applications tend to use multi-tier architectures to ensure high availability and performance. That marks the end of it.
Right. Thank
you.
you for listening to our little presentation from group 6 about server system architecture. We sincerely apologize if there were any mistakes. I'm sure there are. And hopefully you learned something new. Thank you very much for watching. All right. Great job.
Okay.
Right. Here's one more thing. Before I end the meeting, for the document, I feel like we should add images, everyone, like any relevant images. And then after that, I'll tidy it up, and then I'll tell you all if it's finished, and we can all submit. All right.
Okay.
All right. Thank you very much. Let's leave the meeting.
Yes.
Like, let's go ahead and meeting.
Oh.